This is page 2 of your 4.4 notes. For some reason, when I made this video, it didn't save to YouTube and I already threw out my empty copy. So I'm just going to go through and talk about an already filled out note-taking form. So just follow along and we'll see how this goes. Just a couple of reminders. We have 3 different properties that you've been working with. The product property says that when we're multiplying 2 things together of a logarithm, we can split that up by adding them together. It also works in the opposite direction, which is saying that if you have addition between 2 logarithms that have the same base, we can condense it by multiplying the 2 things together. Quotient property, if you're dividing, you subtract, or vice versa. If you're subtracting 2 logarithms with the same base, you can condense it by dividing. Make sure you put it in a specific order. The u must come first or be in the numerator. V must come second or be in the denominator. The power property just says that when you have a logarithm where you're taking the log of an exponent, you take the power and you put it out front. So then we would have n times the log base b of u. For the first set of examples, we're going to be expanding. So notice how this is one nice logarithm. We need to expand it all the way out. So we're making it so that we're taking the log of each component. We're going to use these 3 properties in order to do this. You need to ask yourself, okay, what's the big picture here? We have a quotient in this first example. And whenever we have a quotient, we're going to use the quotient property, which says that in order to break this apart, we need to subtract. We need to put our numerator first and our denominator second. So you see I wrote log base 2 of the numerator minus log base 2 of the denominator, which I wrote here. When we have 7x cubed, you cannot pull out that 3 right away. This 3, like I say here, only belongs to the x. So what we really have is a 7 times x cubed. So this right here, if I were to expand it, I need to use product property. When we have 2 different things being multiplied together, we break it apart by adding them. Notice how in my next step, I have log base 2 of 7 plus log base 2 of x cubed. And then I brought down that minus log base 2 of y once again. This is not all the way expanded. Now I'd have to use the power property. And the power property says that if we have an exponent, we can bring that power out front. Again, we didn't do that earlier. We couldn't bring the 3 out earlier because it didn't belong to both of these terms. It only belonged to the x. So when I bring my exponent to the front, it needs to go in front of the logarithm that contains the x. Essentially, when you're expanding, you need to use the power property last. Keeping that in mind, we're going to take a look at the next example. We have log base 5 of 2 times x to the 6th power. That 6 only belongs to the x term. If it were to belong to both of them, there would be a parentheses around this, and there's not. So big picture is we have 2 times x to the 6th power. I need to use product property, which means we have log base 5 of 2 plus log base 5 of x to the 6th power. Oops, I just realized there's a 2 there when that should be a 5. Fix that again. Okay, I cannot expand this any further, but I can expand this one. There is an exponent, so using power property, I'm going to put that 6 out front, making this my final answer. Condensing something is when we have an elongated expression, so multiple logarithms, and we want to condense it into one logarithm. This is kind of the opposite of what we just did, like I said, but also in the way that we approach it. Before, when we were expanding, we did the power property last. Now we're going to do the power property first. So when I look at this first example right here, there's a 2 out front of the log of 2. So I need to put this back in the power position, which leads me to this next step that I put here. Log of 6 plus log of 2 squared minus log of 3. Well, 2 squared is 4. Now I'm going to combine. I just do it from left to right. So I start here. I have log of 6 plus log of 2 squared. When we add, we know we multiply the two things we're taking the logarithm of. So that's 6 times 2 squared, or 6 times 4. And you need to bring down that minus log of 3. Then we're going to condense this to one logarithm. 6 times 4 would have to be divided by 3, because when we subtract, we know to use the quotient property. So my next step, you can see I have 6 times 4 all over 3. I can clean that up though. 6 times 4 is 24. 24 divided by 3 is 8. So the final answer is the log of 8. A couple of things I want to point out. You can only expand and condense when you have the same base. So you would have noticed in my first two examples, I had a log base 2, so I brought log base 2 every single time I was expanding. Or here I had a log base 5, so I put log base 5 each time. For this example we just did, it's the common logarithm, which is an understood base of 10. If you want to write the 10, that's fine. Otherwise, you don't have to. It's understood. But as I'm condensing, I could only condense them because they all had the same base. If they had different bases, I would not be able to condense them. All right, the last thing I need to review is that when we expanded, we did the power property last. When we condense, we do the power property first. Keeping that in mind, we're going to do this one last example. I know that there's a power if there's a coefficient out front, so I see there's a 2 and a 5 in front of the logarithms. So this 2 is going to become the power of 7, and this 5 is going to become the power of the x. So it's log base 3 of 7 squared minus log base 3 of x to the 5th power. Now these both have a log base 3, so I can condense it. Because it's subtraction, I know I need to use the quotient property. Make sure the first term goes in the numerator position and the second term goes in the denominator position. And you always want to simplify your answer if at all possible. 7 squared becomes 49, so you should write your final answer as log base 3 of 49 over x to the 5th power.